Okay, so in these last two, so problem 24 and 25, in 24, we are, you could think of this as the same way that, okay, I'm given this, I got to calculate the pH of a acid solution, but in this case, I'm given, and you're going to be looking for this, because this signals that we're using a buffer. We're now constructing a buffer. We are making both, we're given both the acid, so that formic acid, right, that thing, and we're also given the conjugate base to that, this stuff. So we're given both. We're given both acid and conjugate base and the Ka. And that should be a big signal goes off saying we're going to use Henderson-Hasselbalch, which is this equation right here. So it's the pKa plus the log of the base over the acid. Now, you could start to write out this equilibrium, and you could do it this way, but it's long, and it's going to take you more time. And so when you're given both the acid and its conjugate base, or the base and its conjugate acid, we go straight to Henderson-Hasselbalch. So we're going to take the pH is equal to the pKa, so that's the minus the log of the Ka, we're given that. And when I do that, that's 3.75, plus the log of the concentration of the base, and the base in this case is the sodium formate, right? That's this thing. And we're also given the acid. That's going to be concentration of that base over the concentration of that acid. The acid was just given here as formic acid. So that's on this side. That's that stuff. And then we can't crank that out, and that turns out to be equal to this pH equal to 3.910. That's a very straightforward example of when to use Henderson-Hasselbalch. You're given both acid and its conjugate base in the form of a salt. Now in 25, it's just phrased a little bit different, but doing the same thing. So what is the pH now when we mix these two things? And it doesn't tell you straight up that these are conjugate acids and bases, but this is what you're looking for. You got to be able to recognize acid and its conjugate base. And so we're said, okay, we have 50 milliliters of this ammonia solution that is at 0.1, and that means in our final solution we're going to have this many moles of ammonia. And then this, you're going to recognize this is the conjugate acid and base pair, right? We got NH3, NH4 plus. They are different by a proton, conjugate acid base pair. So this is the salt of a weak base, and that is the prescription for a buffer. So we figure out how many moles of that do we add, and then it tells us that these are additive. So we've got this many moles, 50 milliliters, this many moles and 55 milliliters. It's still going to be the same thing, except now what's different here is it gives us the Kb for ammonia, and in Henderson-Hasselbalch we got to use the Ka, so it's equal to the pKa plus the log, still going to be the base concentration over the acid concentration. But we got to calculate this Ka because we're just given the Kb. So it's going to be this same idea. Ka times Kb is going to give us, it's got to equal Kw. So to calculate that Ka, it's simply going to be the Kw divided by the Kb. So in this particular case, this pH is going to be given by do I have it written down here, what it turned out to be? It turned out to be equal to 9.26 plus now log of this base. Now the ammonia is the base, so we're going to put that as the 0.005 moles. Now it's over 0.055 total liters over the acid. In this case, that's 0.0005 moles, and it's over that same amount of, so those cancel, right? And it's just going to be a 10 to 1, and so that's going to give us a 1, and so this is going to be 9.26, and we add to it 1, and that gives us our value of 10.261. This is 0.005 divided by 0.0005. We take the log of that, and that's going to give us 1, and that's our answer then for number 25.